Hi kids, now we will be going with this long simple pendulum and what is its time period if at all its length is going to be very large. So first of all we will be talking about what is the situation we are dealing with, long simple pendulum. So basically we are taking a pendulum and we are fixing somewhere here where this length is comparable with the radius of the earth, and that pendulum is going to perform oscillation in the surroundings of the earth, so that is G value is almost same, but that G value will be towards the center of the earth. So when it is performing that curvilinear thing, we will be writing torque equals to I alpha and we will be seeing SHM form, right? So we will be writing torque about this point. So torque equals to I alpha, torque due to tension is 0, torque due to weight we need to find. Now before that, let me do something. Let me call this angle is theta, this angle is phi. So if I take this length is small. So if I take this length, those angles are also small. So this will be L cos theta, this length will be L cos theta, and this will be L sin theta. So this will be almost L and this will be almost L theta. Now this length is R. So I can say this length is going to be almost R only, R by sin phi, right? R by cos phi. So this will be tan theta equals to opposite by adjacent. Then you will be getting this is R phi. So the relation between theta and phi is L theta is R phi. So I am taking this as theta, this as phi. So from this triangle I am getting this as L theta. From this triangle I am getting this as R phi. So the relation between theta and phi is this much. Now I need to take torque about this point. Now when I take torque about this point, then R bar cross R bar cross F bar I can write. So R bar is in this direction, F bar is in this direction, angle between them is theta plus phi. If this is phi and this is theta, I can show you this is going to be theta plus phi, because this is 90 minus phi, this is 90 minus theta, but the overall angle has to be, or is this outside angle, right? So you can get this angle, fine. So then you will be going with R bar cross F bar, then you will be getting mg L sin theta plus phi, but theta is in this direction, torque is in this direction, so opposite direction. Torque equals to I alpha. Now moment of inertia about this point is ml square. Torque equals to I alpha. So now alpha is nothing but the rate at which it will be changing, right? Alpha is theta double dash. Alpha is theta double dash. So we need to convert this thing into theta form. Now theta and phi are small, so I can write this as almost theta plus phi, but phi is again variable, but we need to write phi in terms of theta, so I will be using this and I will be writing it. Now I can show you this is of SHM form. Theta double dash equals to minus omega square into theta. Then time period will be t equals to 2 pi by omega. When I substitute, I will be getting this thing. Now once I get time period as that thing, if length of the pendulum is very small when compared to the radius, then I will be getting 2 pi into root L by G, which makes sense because this is how we will be deriving time period of our general pendulums, where the length will be very small when compared to the radius. Now if length of the pendulum is much greater than radius of the earth, then when you substitute those things, when L is much greater, when you substitute it, you will be getting 2 pi into root R by G. Now this value you have seen already in the, so there was some SHM and tunnel question, probably I was recording on the same day, so those who are watching, I don't know whether you can figure it out or not. In SHM there is some tunnel question where you will be getting the time period as this thing only if you do. So that value will turn out to be 84 minutes, something like that. Anyway, so that's how we will be dealing with time period of long pendulum, right?